So, agenda for today, we're going to review Friday's daily assignment, go over the format command really quickly again. We're going to talk about zero and non-zero and if statements. We're going to review logical operators, and then we're going to talk about storing decimal results in integers, and if we have any time left over at the end, we're going to talk about comments too. So, today is essentially a day where I'm just going to talk about a bunch of things that I've either very briefly talked about or kind of glanced over. I think that's the term you would use. So kind of just a bunch of minor things about the major concepts we've talked about in the past couple weeks. So right now, any questions or comments about the assignment that was due on Monday or the assignment that's due today?
The assignment that's due today, assignment 4, how would we not, and when I'll ask later.
For assignment 4?
Yeah. Like, I have everything coded correctly inside it's compiling, but it's just not selecting what I want it to do. Like, it's not pulling from one function to another.
Alright, that sounds like a pretty specific question, so yeah, we can talk about that later. Alright, so recall I was talking about test 1 earlier. We're going to have that a week from today. So the terminology I've talked about before is now posted in week 6 on D2L. There's 20 questions and then answers. So they'll be the exact questions that will be on the test. So just look at them, make sure you're familiar with the terms, and you should have no problems answering the quiz component of it.
These are like test questions. So some of these you get on the test.
Yep. So anyway, after you finish the quiz test component of the test, there's also going to be a short program to write, so just keep that in mind, make sure your computer's charged and ready to go for that. So I'm just going to go over Friday's assignment really quick. So recall that we're going to write a bunch of functions. If a computation or comparison is occurring, the function should return a value. Return 1 for true and 0 for false in the event of a comparison, and print the return value from the functions. So I'm just going to go through all the different types of functions that we dealt with in this assignment and just talk about them a little bit. So the first category of functions is the 2-parameter functions, and they return a result. So add, subtract, multiply, and divide. Take 2 parameters and return a single number. So there's 2-parameter functions that return 1 or 0, larger and smaller. And there's 2 parameters that don't return anything. So with our compare function, it takes 2 integers. The first one will compare to the right one. It'll print out whether the left is greater than, equal to, or less than the right one. The single parameter functions, and then return a result, half, square, and cube, and then no parameters, no return. So these are our void functions, and inside them we just say hello or goodbye. So I'm just going to go through real quick, write one of these functions a piece just so we are all on the same page. So add So recall that when I was talking about returning, there's really 2 ways we can approach this one. We can either immediately say return A plus B, or we can say declare an intermediate variable, or just a variable that we can use to store our result. We can say int C and then C equals A plus B, and then return C. Now we could also do something like this, just to keep in mind. We could do int C equals A plus B. That's completely valid too. So that's one function that returns a value that takes 2 parameters. So our main would look something like this when we're calling that. We'd say, we'll call it x, y, res. So at this point, we've declared 3 variables. Recall what we want to read into 2 of them, so we just scanf then say store in x and store in y. So in the way we'd call add, we'd say add x comma y. Now we can one thing that I kind of glossed over was we can call functions that return a value, and we don't necessarily have to store that return value anywhere. If we call a function that has a return value but we don't store it anywhere, it's just dropped. It's just ignored or deleted or however you want to refer to it as. But in order to complete the assignment, we wanted to store the return value from the function that we called into a variable. Now, the variable that I have is called res. So we say, this is read as, call the add function with parameter x and y, and store the result, what's returned from the add function, into res. So to print off res, we just say printf %i, add a new line in our printf2, and then res. Now I noticed that some of you did use floating point numbers. That's fine too. Doesn't really matter. I was perfectly fine with using integers just because it's shorter to type int than it is to type float. It doesn't really matter if even your math is particularly correct. The whole entire point of this assignment was just to get you acquainted with functions and feel mildly comfortable with using them. So that's our first function that takes 2 parameters and returns a value. So the second type we had return 1 or return 0. So we still say int because 1 and 0 are still whole numbers, they're still integers, and we'll just say larger. Int a, int b. I'll change my variable names up a little bit here. We'll say lhand, rhand. So remember that we can title our parameters whatever we want to. They don't have to be a and b. They can be literally whatever we want them to be. So we just say if lhand is greater than rhand, then we're going to return 1. Else return 2. Not 2, 0. Wrong. So when we call that, we'd say larger, and then this should print out oh, yep. Yep.
What would it say if you gave that return to? You just throw an error.
What do you mean?
Or that
So if our first parameter is greater than our second parameter, it will return 1. Otherwise, it would return 2. It would literally say 2. Because recall that when we call our larger function, 1 and 0 don't necessarily have any particular value. I could have said return 100 if it's true and negative 100 if it's false. It's just values associated with true and false. And that's something we're going to talk a little bit more about today is why I wanted you to return 1 and wanted you to return 0. Yep.
It has to be numbers to it.
At this point, that's the only thing we can return from functions. So just keep in mind that whatever we say here for our data type for our return value has to match what we're returning. So we have to say, if we're saying int, then we have to return a valid whole number. So let's see. So I print 0 because the left is not greater than the right. So that's our 2 parameters. So 2 parameters, no return void. So recall we say void when it doesn't return anything. Compare. B. So if, I won't complete this whole one, but this is essentially how it'd be structured. You'd say if A is greater than B, print A is greater than B, else if A is less than B, print A is less than B, and then else print that they're equal. Now, something to keep in mind that when we're writing if statements inside our functions, we can return at any point. So if I was to say return here, return, execution would immediately stop. We wouldn't check any other conditions or execute any other code inside the function. So we could have instead of structuring it like this, we could have said print, or we could have said print and then return. Just that's going to be expanded to what you'd actually print. And instead of saying else if, we would have just said if again, and we could have print return if, and then since nothing else would be true, we just we print here. So this condition will only execute if it's greater than, and if it is greater than, it's going to immediately end the function and continue executing back inside our main or wherever else we called the function when we say return. So you could have either done if, else, or you could have done if, return, if, return. Does the return kind of make sense a little bit? Hopefully. You'll get used to it. It's not necessary to really do this at all. It's just trying to expose you to some different ways of doing things. So single parameter return result. So for the half, cube, and double, I just wanted you to select either A or B or any other number. It didn't even have to be any specific value. We'll do cube. Param. And then we could say return param times param times param. And that would be how we would do cube. And again, we could do a temporary variable inside our function if we wanted to, or we could immediately do the calculation like this. So we could do int res equals return res. So look something like that. If you wanted to store it in a variable, if you want to do more calculations on it, you can store it in a variable.
When are we going to learn to return strings and stuff?
So I'll talk really briefly about that. So one of the data types that we use in C is char, which is a character. And later on in this class, what you'll learn is that the only way to represent strings is really a sequence of characters. So the problem being we can only return one thing from a function. So how do we return a sequence of things? So it's a thing that we'll talk about in the future. It's kind of difficult to explain without a lot of background knowledge that we'll cover later, but that's kind of a basis. So that's our cube. So no parameters, no return. We'd say void for no return value. We'd say hello. So no parameters, so we don't specify anything inside of parentheses. We just say puts hello. And that's all I wanted for that one. So that's basically the assignment from Friday. Our function's kind of making sense now. We think we're doing all right. Anything that I can help with at this point that doesn't really make sense?
Is it bad that I have no returns in my thing?
What do you mean?
Never. I'll talk to you later.
Okay. There was one. So where are we at in here? So we're going to talk about the return value from the larger function. So recall we talked about if statements before. We could say if, and then x is greater than y, and then puts x is larger than y. So right now that would print out because it's larger. So recall that larger returns 1 if it's larger or 0 if it's smaller. So what we can actually do with an if statement is instead of providing a condition, we can actually provide a value instead. We can say res. Now what the if statement looks at there is if the value specified here is not 0, then the condition is true. So if we specify any number that's not 0, then the if statement is going to execute. So just for demonstration purposes, comment that out quick. And then we'll say 10. We can say if 10. This will work. I gotta go back and delete some code. I should have just written this out instead of. So we can see that the statements inside that if block executed. And that's because if we specify any literal number or variable containing a number that's not equal to 0, then it's true. So we refer to that by saying a non-zero value is true and 0 is false. So we could say, remember res, so it will contain, I gotta put this back up now, comment out the printing from the addition function. So recall that res will contain the result from larger, so 10, 11. So obviously that's not true, but if we were to say 11, 10, then we'd store 1 into res, and then when we use our if statement to look at res, we'd see that it contained a non-zero value, and we'd assume that condition to be true. So if we specify, so we can specify any number, literal number, or variable containing a number inside our if statement, and it can be processed as an equality. So we could say 10, which is going to be true, it's going to execute. The print statement, we could say 100, it's going to be true. Say negative 100, it's also going to be true. We could say negative 10, it's going to be true. The only thing that's ever going to be false is if, again, the literal number we specify inside the if statement or the variable is 0. So it's only going to print, it's only not going to be true when we use 0. So just keep in mind that 0 is false and non-zero is true if we're specifying literal numbers or variables inside our if statement. So we could say something like this. We could take this and we could go down here, and we could actually specify a function inside of our if statement. We could say larger x, y. So what that will do is the if statement will, so this is essentially red, so call the larger function, and based on the return value, if the return value is 1, then we're going to execute this, and if it's 0, we're not going to execute this. So just try and keep that in mind that we can specify functions inside our if statements if we have complex conditional things that we want to test, or things like that. So just think about it like, so what this is going to do is, based on the return value, this is either going to become a 1 or a 0 inside of this. And 1 is true and 0 is false at a very basic level. Really quick, I wanted to review logical operations. So recall that we can specify multiple things being true. We can say, and if we have, we can say 2 and ampersands if we have 2 things that we want true. We could say addition A, say x is greater than y, and x is greater than or equal to y, which that's not going to work. We'll say equal greater than. This is kind of just for demonstration. These aren't meant to be real conditions. So you can say 2 conditions, we can string them together. We can say this condition has to be true here, and this condition has to be true here. So we can do that with functions too. We can say x is greater than y. We can say larger x comma y. Because again, 1 is non-zero is true and 0 is false. Or we can say or. So if either of these 2 conditions are true, then we'll execute the statement inside block. So there's actually a third logical operation that we can use, and that's the exclamation point, which essentially says not. So it will invert the trueness or falseness of a statement. So if x is larger than y, when we say exclamation point or not as it's read, it would invert what this is. So this statement will never be true because x is greater than y here, which will be true if x is greater than y. But since when we pass in x and y in this case, it will return 1 if they're greater than, but this will essentially invert that trueness. Now that's kind of a hard concept to understand, but it's important. So just keep that in mind. We'll talk more about it later when we get into building more complex if statements. So essentially what you could have done is if you wanted to write a smaller comparison, you wouldn't necessarily have had to write a smaller function. You could have just said not larger. So, or you could have said, if you had written your smaller function, you could have said smaller, and you could have said not small, not smaller. So it just inverts the return value of the function. So kind of an interesting piece of functionality.
So for that to happen, what has to be smaller?
So recall that our smaller function, as we would have written it, would have returned 1 if x is smaller than y. So, and 0 if y is bigger than x. No. It would have returned 1 if x is smaller than y, and it would return 0 if x is bigger than y. That's what I mean to say. So if we put the exclamation point, that inverts the sense of the return value. So instead of this returning 1 when it's smaller, it would essentially be 0 when it's smaller and 1 when it's bigger. So these I'll just write this out. We could say this 2 times. So these two cases are essentially equivalent. So we could say not smaller, or we could say directly larger. So these can be seen as the same thing. I'll write out the traditional way of writing it. We could say x is greater than y.
So if we put the y where the x was, it would be y is larger than x, if for that to output.
Yeah, so if we wanted to test and see if we could change the x and y around, that's no problem. We could say y is larger than x. That's not a problem. So all of the when I run this, never mind. I'm not gonna run it. Whatever. Close enough. But just think about this. All of these 3 statements do the same thing. They all are going to print out x is larger than y because their condition is dependent on x being larger than y. But they're all going to do it for slightly different reasons. So, some interesting functionality. So, let's see here. One thing I want to talk about while I have all these if statements just lying around here is, hey guys, one thing that we can do is if we only have one statement that's executing in our if block, we can essentially remove the brackets. So we can say something like this. So instead of putting all those brackets, if there's only one statement after the if statement, then we don't have to specify any brackets. So we can simplify all our syntax. This will still execute exactly the same way. It's just that if there's one statement, we don't necessarily have to use the brackets. It's nice sometimes because you want to make sure that anyone reading your code understands exactly what's going on, and sometimes this syntax can be a little off-putting. For instance, if you didn't put any indentation or something like that, I wouldn't be able to read through that code immediately and understand what was going on. So for very simple cases, you don't need the brackets. You can just remove them if there's one statement, but I typically recommend leaving the brackets in because it enhances readability. So, let's see how much time we have here. So, another small thing I want to talk about today is dividing. Let's say we're going to divide a number. Let's say we're going to divide 3 by 2. So we have int A and int B, and in A we have 3, and in B we have 2. Where is that coming from? Bad. Bad. You look like you had a guilty look on your face. So I'll just clear all this out quick. So I'm going to read in two numbers. That's not what I wanted. I'm going to read in two numbers like we've been doing so far. And we're going to look at what happens when we take res and set it equal to x divided by y. And then we're going to print out the result. So recall that all three of these variables are integers. And let's just run this program real quick. So 3 divided by 2 gives us a result of 1. So that might seem like kind of an odd function at when you first think about it. But what essentially happens when we're working with integer values and we do an operation which results in a decimal, when we store that value in an integer, it essentially just drops the decimal component of it. Because 3 divided by 2 would have a decimal component. It would be 1.5. But since we're storing it inside of an integer, we're just going to drop that last component of it.
So can you store regular integers in functions just in case someone inputs a...
What do you mean store?
Like, can you just do a function that's just 10?
I don't understand the question. I'll talk about a few more things, and then you can ask again. Maybe it'll clear some things up. So again, an integer divided by integer stored in an integer. If there's any decimal component, it'll just drop it. But what we can do, we can say float, my float, and we can store x divided by y in my float, and then we can say print out the float instead, or the floating point variable. We'll do 3 and 2 again. So we notice that even though we took two integers and divided them together, they still stored their result as 1.0. So again, that's kind of odd. And why is that happening? So we're still dropping the decimal component of our integer division, even though even though we're storing the result in a floating point variable. So essentially what we have to do is do something called typecasting. Now this is kind of tricky. We'll talk about it more later. But I just wanted to let you know that this is a thing that you can do if you want to divide integers and store their results. So instead of just saying x, we can say float x, like this, and then say parenthesis float y. So what essentially this reads as, convert the integer x to a floating point variable, and then convert the integer y to a floating point variable, and then divide the two. So and then we'll store the result in my float. So what this will end up saying, hopefully, if I did it right, is we'll be able to take our result of 1.5 from our integer division and keep the remainder. So if we want to use integer variables, then we need to essentially convert this. This would be read as convert x to a floating point number and then divide it by y, which has also been converted to a floating point number. Now I'm just going to test something really quick here. I don't know if this will work or not. I don't remember for sure. Yeah, so this also works. So I want to explain this one too. So if we take a floating point number and we divide it by an integer, then it will implicitly be a floating point number. This will be, or y will be implicitly converted to a floating point number. So if we wanted to divide an arbitrary variable by another arbitrary variable, all we have to do is make sure that one of them is a floating point number to start with. So if we said, we could either convert one of our variables to a floating point number, or we could say float a equals 10 point, or we could say float a equals 3. And then we could say a. So again, so if we take a floating point number and we divide it by an integer, the result is automatically going to be a floating point value. So 1.5. So if we have any problem storing the remainder, or you're confused about why when you're dividing your integers you can't store it in a floating point variable to start with, or an integer variable at all, just keep in mind that either one of the components of your operation has to be a floating point number, or it has to be converted or typecast to a floating point variable. So one of the things you might have noticed me doing is commenting out code. So what this does, we'll go back here. Let's see if we had. So let's talk about comments really quick. So what comments do, they're used to explain components of our program. So what we can do is we can essentially write comments throughout our code and explain what's happening and what's going on. So there's two types of comments that we can use. We can use a line comment, which is 2 forward slashes, or a block comment, which starts with a slash asterisk and ends with a asterisk slash. So I just want to demonstrate how that works really quick. So I can make a comment and say, this is my hello function. And regardless of what's inside that comment, that entire line is going to be discarded. So everything that you see in blue here, this can have whatever syntax you want it to. It's completely discarded by the compiler when it's building our program. So one of the things you might have noticed me doing down here, guys, is there a problem here?
No, I'm trying to figure out how to run this one second. You can continue.
I'm good.
Yeah.
Just don't. So you might have seen me earlier. What you can do is if you have a line of code that you want to save or something, but you don't want to remove it from your program necessarily, you can just comment it out really quick. So you can say 2 forward slashes, and that line won't execute. So you can see in my editor, it will turn blue. So that means that the code's not going to be interpreted by the compiler, and it's essentially just going to sit there. So that's that's the basic uses of a comment. We can explain functionality. So if we needed to, let's say we wanted to explain what our larger function was doing, we'd say return 1 if LHAND, if greater, return 0 if less than. So if we have complex operations that are going on that don't make sense to a reader, we might want to add some comments to say what's going on. And recall that when I say 2 forward slashes, I mean this is the symbol that's referred to as a line comment. So it will start at the beginning of the line or anywhere at the anywhere during the line. We can start after a line. We can say my function. So that's a valid comment too. It won't interfere with the syntax. It's just used to explain things. So again, what a line comment does is as soon as we see the 2 forward slashes, we disregard everything after that. So when we get to some more complex code, I'm going to require you to comment things and explain what's going on. So both you understand it and I understand it better. The second type of comment I can talk about is the block comment. So that opens with a forward slash and ends with an asterisk and closes with a asterisk and forward slash. So let's say I have this function hello and I want to just completely delete it. I can say, or I don't want to delete it, but I want to keep it in the code. So I can say forward slash asterisk. I can go below the function and I can say asterisk forward slash. And you can see all that stuff in blue. That won't be interpreted by the compiler at all. It'll just ignore it. It'll stay in your code, but it won't be built into anything. Now you can't use the hello function anymore. We have to remove the references to it in main, but it's just existing in your code now. Now the block comment doesn't necessarily just have to be used for commenting out blocks of code. It can also be used to explain more complex things that we can't do on one line. So what my editor will do is if I start a block comment and I continue on, it will automatically add another asterisk. So I can say my main no return nope return int. So that's essentially a comment that just describes what that function does. It just says it's my main, it doesn't take any parameters, and it returns an integer. So we don't need the asterisks on every line. That's not necessary. We can just say, all we need for a block comment is forward slash asterisk, and then asterisk forward slash. So that's pretty much it for today, I think. Just wanted to really quick talk about the format command again. If you do have some source code that isn't indented properly, you can just do format and then -i in your file name. And what it'll do is it'll go through and it'll just instantly fix all of your code. It'll indent it. It'll put brackets in for if statements. It'll do a bunch of good stuff. So again, point of the day was I just want to cover a bunch of things that I've kind of glossed over. I know I was going in a bunch of different directions, but there were just a bunch of things that I realized that I hadn't necessarily talked about. So yeah, that's it. Make sure you turn in an assignment for tonight if you haven't done so already. I'm gonna also take a point off if it's not formatted, like indented a little bit. So if you submitted it and it's not indented properly, then just run the format command on it and it'll be acceptable.
Hey.
What now? Like a question you want me to? Hey, David Carter, just.
You know we're all thinking about
Always your program, so you know
Have a good day. You too.
Wait, Alex, do I need to say to her was I good today? Are you gonna yell at them?
Yeah, we're in trouble.
You pissed me off.
What's the question?
If we've already submitted it, he wants to go format it. You guys fucked up. You gotta be like me, just surf the internet all hour.
So it's all left assigned is assignment, left assigned is call.
There's that.
I think he actually wants to be.
Some setting in a wire and change it.
I think you should, if you need to change your first one there to 0.
Yeah, so. Well, I've decided that. Well, there's a whole tournament for the league. It's a 33 tournament, and I'm going to go win it.
Have you on your team?
No, because you have no responsibility.
I do.
Am I allowed to just sit there and yell? Yes.
I'm sorry. Good go to.
Oh, it's terrible.
Or Heroes of the Storm.
Heroes of the Storm is also horrible.
League is horrible.
So you said
The community is horrible. Right
Let's
over
open
the
up
game,
your
the
rectangle.
community is terrible, but
let's go
the
and
game plays
scroll
better.
over to
I they do it from
I would think.
We
And
did.
I can prove you wrong now.
there. Okay. I'll talk to you later and
You
take me.
started out, you're like, yeah, everyone's got their own opinion. Yours is wrong, but you have a different one.
God, what is this Nazi Germany?
Oh, it's not.
I know. I should be able to express myself freely without being
Oh, you
accused.
really?
So you need to where you
You are being mean, so you should be judged.
No, even that.
I don't know. He can accuse me like a dirty Jew.
You know, we don't. I'll just tell
so just scroll back up.
Good luck with that, but we can if you want.
So instead of declaring all these variables there,
Nobody.
You not see his beard. What you're saying? I'm terrible. Like oh, he doesn't have a beard.
He can't grow a beard.
That is your first.
If you had like a neck beard, like you
Right after
this
the
clean.
scanner,
Yeah, that's what it means. You're good. No.
See, when you have one like this and longer, you're good in life.
so just try and
It is true.
You're good at life.
Dollar Beer Club, isn't that?
The what?
Dollar Beer Club, whatever. Like you get like $1 a month, you get like all this beer and shit.
Oh.
And I went to a big party in Bulgaria, and it was so great. We just had like 10 guys with big beers and like 200 girls.
Beers are great,
It's
bro.
pretty good. So I'd go back and I'd clean up that.
Maybe Alex just wants to know what the total part.
Solid.
I don't think that's it. That's it.
It's definitely up into
Oh, I don't know what's gonna happen, but it's going to happen.
Work on it a little bit more. If you don't, if it doesn't make sense, just email me.
So this is the
Always
like it compiles and everything.
And then
But when I go to
November
it
8th?
doesn't. So I'm just curious on how I can
That was
get
like
that.
a.
So, like,
that's in Fargo. But we're I'm finally ungrounded on Halloween
Why were you grounded?
That's the day after Halloween.
for the last weekend.
Your parents grounded you?
No, I had this
We need to have we need to have which
I was trying to say.
His mom's
But it's two different
stuff.
So what I would do is I would place all of these with like
We take this to one.
Why don't you have shoes?
Right there. Just walk around.
And then afterwards, I'd say
And I had a talk for like 45 minutes with my RA where he was like, yeah, but why everyone on my floor?
so you have to have after you read it in,
There's
you
so
have to have
there's
some way
Yeah.
that you have to process what the user and put it into all function space. So kind of build it like that. Again, if you have any problems, just
I don't have any stories about it.
4 or 5.
thank you.
So I never declared smaller. So I just never had the function smaller. So that's what happened. When I don't write there, I didn't write smaller inside my function.
You're up.
So we
We
never
should just like
declared
say you
smaller.
guys took it
Yeah,
apart.
we have to always declare smaller.
You just walk away.
We have to actually write that function.
Oh, you didn't need
And that's a function that we write. So you have to write that function. That's not everywhere.
According to other people that I went and studied abroad over there,
Well,
apparently
dude, they're gonna get kicked out. So.
Can I get my backpack?
because
laughing?
I just
I'm sorry.
We were.
You just can't do it.
Is that Rico?
I know you're just playing games, so.
I didn't play it. No.
He was actually good today.
I was just surfing the internet looking at the trailers for bringing people back.
Are you ranked or?
Do you actually play?
I have 30, but I don't play. I hate that game. It's garbage.
Oh, it's no. The community is garbage. Besides that, if you meet everyone, it's a fun game.
Yeah, I'm not good enough to.
I've played for 6 years. Oh my god, I can teach you so much.
Dude, I live
Did you see
in.
Blaine like talking to you about this ever?
No.
I've played World of Warcraft for 6 years.
RA last night for a good hour and a half.
About why everyone on my floor is a moron.
No,
like I've played with them before. They're all terrible. Like
Oh, terrible.
I played with them, and everyone's like, "You must suck. You play football."
Alright, brought him to like trying to get him to stop
Shit
talking
out.
about league, and he's
Hey,
like, wait,
hey,
let's get back to league.
Oh, by the way, 2 weeks total party.
Yeah.
Why?
Mason's house having a total party.
I talked about it. Then we're gonna have a costume party. Then we're gonna have a beach out. Then we're gonna have a lingerie party in the middle of winter.
Oh God, you guys.
And then we're gonna start
Just
frat house.
fucking behave, okay?
We're gonna start
We'll
frat
be good
house.
in class.
Madison, I've
Wait,
talked
wait,
about that so
do,
much.
do
Madison
Edmond's
would
guys
never
play
let.
league?
Well,
Yeah, literally.
At least
They,
never
they,
know
they
if
play
you're
all the
not-
time?
Yeah, like he's like
I told you they're like us.
he's either like silver 1 or gold 5. So
Oh, I was gold 5 the last two.
yeah, they don't.
I get to gold, and then I was like, oh. I used to be lucky with the diamond 1 though. Yeah, I beat Iris. Whatever that is. He's a pro player.
Wait, so do you live with Luke too, then? No, that's different houses.
No, we just sleep somewhere.
So yours is like the green one that's like,
No, it's
Yeah,
like
yeah.
a gray.
Blue
It's like a gray.
you know, like
It's
party
not-
this weekend and or it's on people there. Was he there?
No, he was not there at the very first. The very first night where
His
like
house, right?
you know Kat and everyone.
Yeah.
Yeah, so like
We all came
I was
over.
literally there.
I don't remember you being.
I was literally there.
You probably don't know who he was then.
He was there, and then we had class the next morning.
No, it wasn't the next morning.
No,
It was like
It was
Friday
Saturday
night.
night, and then
No,
was-
it was
so-
Friday night that we had the.
Yeah, it was a
we were-
Friday
it
night
was
because then we
Friday
went to
night.
Aces the next day.
Because Eric
Because
Dog and
Aces-
whoever came,
yeah,
we were
oh.
sitting playing games.
that's hilarious. That's so.
And they're like, come to a party.
That's
You got
memories right there.
come to a party, and we're like,
And then we went to
Sounds
Aces the
kinda
next night,
sketch.
and then the next night, I had sex with someone right next to the creek that's by your house.
and he got vacuum cleaner marks all over his body.
So
Do
we
you
got
know,
to 6
you know the cheerleader? Like the
She's
Cynthia?
gross.
Cheerleader,
Nasty
long
as hell.
curly black hair.
Looks Mexican.
No.
Like if
Well,
you put a
I don't know
sombrero-
anybody.
If you
If
go
you
to the
put a-
football game
football
and
game.
look at the cheerleaders, just look curly, like Mexican looking hair.
The one that
This
like
one.
if you put a
Yeah,
poncho on
Dickies,
her,
like,
she's
She's
like
like a
Stomach.
2. Like a 2, maybe a 2.
a DSU 6.
No.
Yeah,
Definitely
a
not.
DSU 6.
This is so impressive to me that you caught on to all of these things already.
Yeah.
I've been here for
Well, that was like
one
my
and a half.
school. No one at my school would date. My high school would date in our school because all the girls were ugly, and so we'd go
Be
date.
nice. Be nice.
We didn't say to their
You don't have
face.
to be outside there.
I've given up on caring sometimes.
No, like my school, like in high school.
Yeah, I know, but I'm just saying.
Oh,
They might hear some part of it.
Gotta keep a good image of yourself.
I have a great
Give me
image
like
so
a
far.
week, and I'll
It's not
play
in class,
anyone
I'm
that
not
you
in
want me
class.
to, and meet, I'll beat them. I swear.
Like 1v1 mid or like what?
I can already tell you.
Wait, we gotta set Alex up this weekend with the girl.
Yeah,
See,
Alex.
he already
Alex.
talks more than I do.
You're getting laid this week. This is what's gonna happen.
This is so dumb.
This
You're
is
having
what-
I
wait.
can't even imagine this conversation coming up.
Okay, can I just say
like,
now?
dude, Alex
I
is
know.
lame.
Yeah.
3 girls on a futon next to your bed, and
I do not have a futon in my room.
Wait, as like, dude, 3 girls were gonna sleep with Alex, and he put all of them on a futon and said no. I'm like, wait, what?
That was not the case.
That's
And
what-
it's
that's what we
That's what
heard.
exaggerated
said.
the crap out of that story.
How that happened?
I don't want to talk about it.
Oh,
I'm not
so
talking
yeah,
about it.
that's how it
I'll
Tell us.
talk about it when you graduate.
So,
you're not even graduated yet.
so,
Yeah.
so,
I'm graduated. I have a degree.
so you're saying they walked
But
in
you're
naked?
saying for
people?
No, so he's technically good.
Well, technically, I could do whatever I want, and nobody really cares. But I just
I mean,
He's still trying to keep an eye on.
gotta keep a good image, you know. Can't be spreading all that. You just don't. If you talk to I'll straight up fail you.
It turns out the
Oh.
recording is still on.
It actually is. It literally is, guys.